right, so we are on to our next functional group, and that is going to be the hydroxyl. Okay, so first let's start with our general structure. So what we are looking at, again, our functional group is the hydroxyl, and our focus here is the OH. Now, it is important to remember, a lot of times you will see OH written literally just as this, right, connected to some R group. Important to remember that that oxygen does have two lone pairs, because it does impact the way that it behaves. All right, as far as our families go, we have two classifications. One is an alcohol, and that's going to be not an aromatic. Okay, so your R group will not be an aromatic. And a phenol is where your R group is an aromatic. And so I have the pictures of what a phenol looks like right here. All right, so let's talk about our properties, and in particular our intermolecular forces. So because of that OH group, these are going to have hydrogen bonding. You have hydrogen bonded to an oxygen, and this allows for hydrogen bonding. And again, because of that oxygen, and that oxygen has those two lone pairs, it is going to be a hydrogen bond acceptor. And that hydrogen will be a hydrogen bond donator. So that is going to play a huge role in the way that these alcohols, these hydroxys, behave. Okay, so let's talk solubility. So for small alcohols, they are going to be soluble in water, and this is due to the fact that they are going to be available to hydrogen bond with water. Okay, so if you have a very small, small nonpolar region, that's not going to be enough to disrupt that hydrogen bonding. And essentially what you have going on here is there is an energy investment of that water to hydrogen bond to those OH groups versus how much energy it's going to take to disrupt those dispersion forces, and which is more energetically favorable. As that nonpolar region gets larger, it is much more difficult for that water to get in and surround that molecule. That nonpolar region really starts to dominate, and that's going to make those larger alcohols nonpolar, or behave in a nonpolar way, and make them not soluble in water. Now, phenol is going to do something completely different. Phenol is going to be soluble in water, but this is due to the fact that it is going to ionize as a weak acid. And as we know, anything that forms an ion, I shouldn't say anything, but in organic chemistry, a lot of times those molecules that are going to form ions are going to be soluble, and that is going to be the reason why. So the fact that phenol does ionize in water as a weak acid makes it very soluble. Okay, and lastly we have our phase changes. Because of that hydrogen bonding, this is going to make the melting and boiling points for alcohols higher than that of halos and higher than that of hydrocarbons.